All right, no funny business here. Let's go jump straight in. Sine, cosine, and tangent, which is what this stuff is about. SOH, sine equals the opposite of the hypotenuse. Cosine equals adjacent over hypotenuse. Tangent is opposite over adjacent. So to complete the following, sine of angle x equals what over what? Sine is the opposite. So what is opposite 6? Or what is opposite x is 6. What is hypotenuse according to angle x? 10. And then this would be the adjacent. So when we're talking about angle x, those are my guys. So sine of x is opposite. That's 6 over 10. Okay, and then we simplify from there and get 3 over 5. Cosine is adjacent. Adjacent according to x is 8 over 10, which then simplifies. Adjacent over hypotenuse. Tangent, opposite over adjacent, that's 6 over 8, which then simplifies to 3 over 4. Now, 4, 5, and 6 are all from the perspective of h. So from the perspective of h, what are my opposite hypotenuse and whatevers? Well, from the perspective of h, 10 is hypotenuse. H is opposite, on the opposite side of it, and then 6 is adjacent. So, based on that, sine of h, sine opposite hypotenuse, 8 over 10, which is 4 over 5. Cosine adjacent, 6 over 10 hypotenuse, and then tangent is opposite over adjacent, 8 over 6. Always reduce those. So I got the sine of a here for number 7. Sine is opposite, which is 2 over hypotenuse, 13. Now I got a little bit of work here because square root of 13, to simplify this, I can't leave that radical on the bottom, so I have to multiply by the square root of 13 over the square root of 13, multiply across, 2 square root 13 over 13. That doesn't reduce or simplify. The tangent of b. Tangent, opposite over adjacent, TOA. Opposite is 3, adjacent is 2, because the hypotenuse is 13, so it's 3 over 2. That doesn't simplify. The cosine of a. Cosine adjacent, 3 over hypotenuse, square root 13. So we have to do the simplification process again. That's 3 over square root 13. It will end up looking like what a did, but where the 2 was, the 3 takes its place, basically. So there's those. That's type 1 type of question that we do with trigonometry. The next thing we do, we solve for missing sides. Can't use Pythagorean theorem, only one side is given. This is not a 30, 60, 90 triangle, so we don't use short leg, long leg hypotenuse business. So this is where we use sine, cosine, and tangent. From the perspective of 35, x is opposite, 20 is the hypotenuse, opposite 90 degrees. So which of our ratios uses opposite and hypotenuse? OH, that's SOH sine. So write the sine of the angle equals the ratio, opposite over hypotenuse. Now I need to worry about getting x by itself. When we're using x as a side in these ratios over here, write it as a proportion. And once you have your proportion, we want to get x and 1 together, get x alone. To get x and 1 together, I can cross multiply. X times 1 is x. And then 20 times the sine of 35. Type 20 times the sine of 35 into your calculator, I get 11.5. Number 11. From the perspective of 41, 11 is the hypotenuse, x is the adjacent. Which one uses adjacent hypotenuse? A and h, that's C, cosine. So I go cosine of the angle equals the adjacent over the hypotenuse. Go ahead and make it a proportion because my x is over here in the ratio. And to get x and 1 together, I will cross multiply. X times 1 equals 11 times cosine of 41. Number 12, the hypotenuse is down there. X is the opposite, 7 is the adjacent. So I'm dealing with the adjacent and the hypotenuse, the A and the O, or the O and the A. That's TOA. Tangent gets me that. There it is, TOA. So tangent of 64 equals the opposite, x, over the adjacent, 7. Because x is on the top, when I cross multiply, I get x times 1 is equal to 7 times the tangent of 64. Type that in your calculator. There's your answer. Here we go. Number 56. X is the hypotenuse, 10 is adjacent. Adjacent hypotenuse is cosine, so I get cosine of 56 equals 10 over x. Here, if I cross multiply, I won't get x by itself. This is where I want to switch the extremes. When the x is on the denominator, switch the extremes. When x is on the numerator, cross multiply. When x is on the denominator, switch the extremes, and I get x over 1 equals 10 divided by cosine of 56. This is what you type into your calculator. 10 divided by the cosine of 56 gets you your answer. Why am I rounding to the nearest tenth? Because the directions tell you to. Will we always do that? No, you round, do whatever the instructions say. Yeah, so there's the same work that's there. Now, 14 and 15, this is interesting how it confuses people at first. But yeah, it gives you both angles. It does not matter which one you use. From the perspective of 23, x is opposite, 6 is adjacent. From the perspective of 67 degrees, 6 is opposite, and x is adjacent. Either way, I'm dealing with opposite and adjacent. That's tangent, TOA, T-O-A. So I'm going to write the tangent of the angle, I'm starting with the 23, equals x over 6. Put that sucker over once, create a proportion. But before I solve it, let me set up the other one as well. Oh, no, I will go ahead and solve it. My bad. I will cross multiply because the x is on the numerator. X times 1 is x. 6 times the tangent of 23 gets me my answer. Now, if I'd use the other variable, the other angle, 67 degrees, it's still tangent, but now it's 6 over x instead of x over 6. Now I don't want to cross multiply. This is where we'll switch the extremes to get x together. X with the 1. X over 1 equals 6 divided by the tangent of 67. It's really cool to do this. Do this. If you're type in 6 times the tangent of 23 and type in 6 divided by the tangent of 67, and you'll incredibly get exactly the same answer. 15 is just like the other one, except for if you use the opposite. For 28 degrees, 50 is opposite. For 62 degrees, 50 is adjacent. So you'll use the sine if you're going to use 28 degrees. You'll use cosine if you use 62 degrees. But to solve it, it's the same setup. Either way. And again, it'd be great to do both of these things. Type in 50 divided by the sine of 28 and 50 divided by the cosine of 62. You get exactly the same thing. So that is how sine, cosine, and tangent work. Our other concept guide will help us to know what happens if the variable is at the angle. But that's how this part works. All right, 16, 7, and 18. This gets us back to the 30, 60, 90, 45, 45, 90. If you don't know the magic numbers, get your notes out for the 8-4 concept guide and for the practice stuff that we've done. It's a 30, 60, 90 triangle because it tells us. The 30, 60, 90s, this is where we're going to talk about short leg, long leg, and hypotenuse. So the short leg is y, x is the hypotenuse, 2 square root 3, which is the number that's given, is the long leg. We will always go to the short leg from whatever we're given, if it's not the short leg. To go to the short leg from the long leg, because we're going bigger to smaller, we divide by what number? Square root 3. 2 square root 3 divided by the square root 3, the square root 3's cancel out, we get 2. Cool. Now the short leg is 2. To go from the short leg to the hypotenuse, smaller to bigger, I multiply by the magic number, which is 2, and then 2 times 2 is 4. On number 17, short leg, long leg, hypotenuse with 30, 60, 90 triangle. It gives us the short leg. So to go to the long leg, we multiply shorter to longer by the square root of 3. 2 square root 3 times the square root of 3. Square root of 3 times the square root of 3 gets us just 3. So it's 2 times 3 is 6. That's what y is. To get x, I'm going to go from the short leg to hypotenuse, multiply by 2. The numbers that are not inside the radical multiply together. The answer is 4 square root 3. Number 18 is a 45, 45, 90 triangle, thanks to the 45 degree angle right there. So 6 is the hypotenuse. To go from the hypotenuse to the short leg, we divide bigger thing to smaller thing, divide. Smaller to bigger, you'd multiply. In this case, we divide by the square root 2. Because both those numbers are inside the radical, we get the square root 3 for our answer. Moving on down the road. Other side, 30, 60, 90 triangle. So this is a short leg, long leg, hypotenuse. The long leg is given. Go to the long leg. To get from the long leg, divide, bigger to smaller, by what number? Square root 3. 12 divided by the square root 3. We've got some simplifying to do now. We end up with 4 square root 3. The short leg is 4 square root 3. How do we go from the short leg to the hypotenuse? Smaller thing to bigger thing, we multiply by our magic number is 2. Two numbers that are not inside the radical, 4 and 2 multiply, and we get 8. 8 square root 3. Number 20 is a 45-degree angle, therefore 45, 45, 90. The hypotenuse is y. The legs are 5 and x, so the legs are equal in an isosceles right triangle. To go from the leg to the hypotenuse, 5 times the square root of 2 is 5 square root 2. On number 21, it gives us the hypotenuse of this 45, 45, 90. So we will divide instead of multiply. Bigger to smaller, we divide. 14 divided by the square root of 2 simplifies eventually and gets 7 square root 2. Number 22. I have a right triangle, 30, 60, 90 right triangle on the right side, a 45, 45, 90 triangle on the left-hand side. The thing that is given to us is the hypotenuse of the 45, 45, 90. We divide by the square root of 2 to get the leg. So I'm solving for x here, the leg of this 45, 45, 90. 8 divided by square root 2. Simplify. Simplify, you get 4 square root 2. Now this side, which was the leg of the 45, 45, 90 triangle, is also now the short leg of the 30, 60, 90 triangle. So I can use 4 square root 2 now to go solve for y and z. To solve for y, short leg to hypotenuse, multiply by 2. To go from the short leg to the long leg, multiply by the square root of 3. The numbers inside the radicals go together, you get 4 square root 6 for z. Number 23, I hope you recognize this as a rectangle / right triangle question. Whenever you have this, we want to solve all 3 sides of the 30, 60, 90 or the 45, 45, 90 triangle over here. The only thing we have here is that's A. That's not going to help us. But, however, the rectangle, let's just pull over, that this side here, the one that I drew, is 2 square root 3. That is the long leg of the 30, 60, 90 triangle. A is the hypotenuse. To get to A, which we've got to solve for, we have to go through the short leg. I'll need that to solve for B here in a second anyway. But the short leg is going to be 2 square root 3, bigger thing to smaller thing, dividing by the magic number, 2 square root, or divided by square root 3. That gets us 2. So the short leg is now 2. Now, short leg to hypotenuse, smaller to bigger, we multiply. Multiply by 2 is 4. Now, what about B? Well, B was the side of this rectangle down here, which got pulled up there. This whole side here is 6. So B plus 2 equals 6. So B equals 4, just like A did, actually. Okay. Next. All right, the perimeter of a square is 88 inches, and the length of the diagonal is blank. Well, what do we know about a square? If the perimeter of a square is 88, and the diagonal is what we're looking for, if the perimeter is 88, can't we divide that by 4 and get that each side is equal to 22? I think we can. So each side is equal to 22. Now here's the special thing about a square. All the angles are either 90 degrees, and then because it's a rhombus, the diagonal chops that 90 degrees in half. That's a 45, 45, 90 triangle. So now we have this right triangle where x is the hypotenuse of the 45, 45, 90 triangle. 22 times the square root of 2 is 22 square root 2. 25 goes the other way. If the length of a diagonal of a square is 6 centimeters, well, it's a 45, 45, 90. 6 is the hypotenuse. I need to know, in order to find the perimeter, what each of these sides is. So I'm going to go 6, 45, 45, 90, bigger thing to smaller. 6 divided by square root 2, simplify, simplify. I get 3 square root 2 is what x is. That means each of these 4 x's is 3 square root 2. Multiply it by 4 to get 12 square root 2. On number 26, the perimeter of an equilateral triangle is 24 millimeters. That sounds kind of like the perimeter of a square, but it's a triangle. So each of the sides is 8. And more importantly, not more importantly, but extremely importantly, is that each of these angles here is 60 degrees. So what does the altitude that we're trying to find do? Well, it splits this bottom 8 in half, 4 and 4, which we kind of probably could have figured that out from this 30, 60, 90 triangle. Which part of the 30, 60, 90 triangle is x, the altitude? The answer to that question is long leg. 4 is the short leg. X is the long leg. 4 times the square root of 3 gets us 4 square root 3. 27 goes in the opposite direction. It's the same setup here. Equilateral triangle. The altitude is 7 square root 3. That's still the long leg. This piece right here, which isn't x, it's half of x, is 7 square root of 3 divided by the square root of 3. That's 7. Well, and so is that, which means that that's 14. That means all sides are 14. 14 times 3 is 42. 28. The sides of an isosceles triangle are 18, 41, and 41. I like to put those that are congruent on the left and right. What's the length of the altitude? Well, the altitude chops the 18 into 9 and 9. There's my 30, 60, oh, not my 30, this is not a 30, 60, 90 triangle. This is, we have to use the Pythagorean theorem. 9 squared plus x squared equals 41 squared. So we solve, you should get 40. And here it goes the other direction. The altitude of an isosceles triangle is 15, and its base is 40. Well, what does the altitude do to the base? Chops it in half. Now I got the right triangle. Pythagorean theorem, because I got two sides of it. 15 squared plus 20 squared equals something squared. The answer to that is 25. So what's the perimeter? 25 plus 25 plus 40 is 90. Number 30. Right triangle, 3 squared plus 4 squared equals 3 squared plus a squared, rather, equals 4 squared. This is not a 3, 4, 5 triangle. To simplify that, we end up getting a equals square root 7. Number 31, same process. 6 squared plus x squared equals 9 squared. That's the square root of 45 is 3 square root 5. When you know two sides of a right triangle, you use the Pythagorean theorem. You must have the numbers 45, 30, or 90 in there to use, or 30 or 60 to use the special right triangle. Square root 2, square root 3, and 2 stuff we've been talking about. All right, there you have it. Let me know what questions you have.